Well, this video is going to be about trying to find the right enclosure for your project. I used to think you bought boxes and then you drilled holes in it and things like that. But I've really gotten into buying equipment that I can repurpose. So it's good for recycling, and it saves you a lot of work sometimes. And it looks a lot more professional usually when you get done with it. So I've been working on preamplifiers and stuff. And I bought that Audio Buddy with the intentions of hacking it. I also have a project in mind of building my own preamp and filter, compressor, EQ, that kind of thing. I want to try out different circuits. The first circuit that I have in mind is an 80 hertz cut filter, 80 hertz high pass, to be able to flick in and out of the circuit. It seems like there's too much low frequency sometimes in the audio that I'm interested in, so I want to get rid of that. And so I found this box online. I was kind of searching for old mixers and stuff, and I have no idea what this thing is. It's called a mixer. It's an Audex. It's very odd though. It has fuses in the front, which I thought, well, that's kind of weird. But it had the right connectors on the back, so that's kind of what made me interested in it. It's got 2 microphone inputs and 3 outputs, all XLR. So I don't know if you've priced out XLR connectors, but they're kind of ridiculous. I guess they're not used all that much, so the price is kind of high, but it's perfect what I want. Be able to mix 2 microphones in. I only need 1 out probably, but multiple outs is fine too. But this thing has really weird other inputs. It's got a speaker input. I guess instead of sending it, like if you have a stereo, instead of sending it to the speaker, you send it in here, and then it does things to it and then takes it on the output. It's also got this super bizarre section here, which is 95 kilohertz input output. I have no idea what that is. It's cabled like a 75 ohm cable TV connector, an F connector. So I have no idea what that's all about. There's an aux. I don't know if it's an input or output. Probably an input since it's next to the microphones. Aux. That might be like a line in. And then it's got 3 power connectors. 24 volt AC, 24 volt AC, 24 volt AC, 3 of them. And they kind of go along with these fuses in the front. There's 3 fuses. So whatever's going on with those 3 outputs, they're powered independently and they're fused independently. So that's interesting. So in the front panel, we've got a power switch on and off. Perfect. We've got a switch here that's internal, external. 95 kilohertz internal, external. So I don't know what that's all about. And then under the mixer, we've got speaker. So I guess as the speaker comes in, you can mix that in. You can mix in the aux, so that's the line in, and then you can mix in the microphone. So maybe this is something for like a PA system in a school or something, or church, or you can maybe have a record player and you can mix that into the PA. Aux, you can mix that into the PA, and then microphone, you can mix that into the PA. So maybe that's what's going on. I don't know why there's 3 outputs. But anyway, nice big steel construction, and it actually came with rack mounting equipment. The guy who shipped it removed those to make it fit in the box, but I have those. So I've taken the screws off already. So let's take this top cover off. Which there we go. Okay. So. Big board with hardly anything on it. So I guess the most noticeable thing is the 3 power supplies. There's AC coming in, and there's bridge rectifiers, so it gets rectified to DC and filtered. So whatever's coming in gets turned into DC. I don't know what happens to it, but it does. And then the microphone inputs, it looks like there's a little op amp over here, a JRC 53534. And so that must be the microphone preamp. Looks pretty cheesy. Maybe there's some gain here in this potentiometer. There's a chip here. what's that chip? It is a 12-volt regulator, 7812. So that's good. And then there's one IC on the board, and that one is a FET switch. It looks like it's a 4060. Oh, it's a 4069. 4066 is a FET switch. I'm not sure what that one is. I have to look it up. But it's got lots of room inside. And then it's got this mystery board sticking up here. I have no idea what that is. So let's take off the stand off here so I can. Ooh, you can see what the mystery board is. And oh, it's got a little connector. So we can pull that connector off. What is it? What is it? 74 HCT 4103 and a 4468 and 4049. Oh, and it's got an oscillator. It's got a crystal on it. So this must have something to do with those weird F connectors. This must be some kind of carrier or something that gets sent out. So it might be that the whatever this thing mixes down to gets modulated onto this weird carrier for, what was it, a 95 kilohertz. So it must be a 95 kilohertz carrier that's modulated with this board. So throw that away. But yeah, the rest of it looks fine. I might leave one of the fuses and maybe remove the other two fuses and put some potentiometer or connector or something on the input. There's a little emitter. There's a LED here that says emitter. So I don't know what that is. It's probably something to do with that weird carrier. Oh, and the 95 kilohertz internal external, yeah. So don't know. I don't know. Anyway, I don't really care. I want to reuse the box. I'll probably leave this bottom board in just because it holds the connectors, and then put in a kind of a mezzanine floor PC board to put my stuff on. Like I said before, I'm really interested in the DBX 286. It looks like a really, really good machine. I should probably just buy one because it looks really, really good on the schematic. I found a schematic for it, and it's got really, really high praise. The microphone inputs on that particular device is the same chip that I'm using on the Audio Buddy, the INA 217. And I think it's using the old, that part, the SSM, whatever it is, 2017. I think it's using that chip, but it's basically the same, exact same design. So people rave about the DBX 286, saying it's super quiet, it's very clean, very transparent. So I think a lot of it has to do with that front end chip. So I've already got that down. I'll probably lay out a PC board and make it look nicer. I want to put in a 80 hertz filter. The 286 has a compressor, real nice compressor. It's not optical. I'm kind of interested in optical compressors. So it's not optical. And it has a de-esser circuit. And the de-esser circuits, what they do is they take out the sibilant sound. So the S's and P's, the plosives, takes those out somehow. They usually have a notch filter at some frequency that you can set, and some kind of compression circuit to take out the highs. So it doesn't do anything until you get a high signal, and then it clamps it down. The only problem with duplicating that circuit is it uses a lot of that chips, the that corporation, which still seems to be in business. They build high-end audio chips, and one of the chips that two of the chips that they build that are really crucial in the DBX 286 are a RMS detector, so AC AC audio goes in and it generates a DC voltage proportional to the RMS voltage of the AC. So that's important to be able to duplicate. And the other chip is a voltage-controlled amplifier. So you can imagine the compressor, part of it is, okay, let's analyze the signal, and then when it gets too loud, we'll turn the voltage down on the voltage-controlled amplifier, and it brings it down. So that's a real simplistic view. That their circuit is extremely complicated, and it's supposed to be a really, really good one. The de-esser circuit also has a couple RMS detectors and other things. So it's hard to duplicate those circuits without spending as much money as just buying one. So I'm going to take a look at doing it a different way, maybe doing it a more simplistic way, and see what happens. All right, I've taken the board out, and let's see. We have this weird section over here for the output. Now I don't know why output needs voltage, but pin 3 is ground, and these are completely separate grounds. So pin 3 is ground and connected to the ground of these capacitors, and pin 2 is connected to the positive end of the capacitor. So this 24 volt AC must get turned into some high voltage, 40 volts or something, I don't know, something, and rectified and put on this capacitor. It's a 35 volt capacitor, so it must be 20, maybe 24 volts DC. So 24 volts DC is across this capacitor and across pins 3 and 2. Pin 1 comes over to the other side of the board, so pin 2 has the signal on it, and the other seems to have power on it. So that's that section. In the middle of the board, let me zoom in a bit. So in the middle of the board is a hex inverter, and it seems to be a oscillator. So it's an RC oscillator, and 3 of the outputs are tied together for more output current, and it's probably supplying the clock for this thing here, whatever that is. And let's see, and then this section over here is camera's not swinging. This section over here is the mixer. So this op amp is acting as a mixer. I'm not sure what the adjustment is here. And then the input section is very strange. It has 2 transistors, so that's the only preamp that's going on here. But the strange thing is these 2 connectors are actually shorted together. So pins 1 are shorted together, 2 are shorted together, 3 are shorted together. So it doesn't matter which side you plug in, it's the same thing. So you can't use 2 microphones at the same time. You can use the same microphone in 2 different slots, but that's all there is going to it. So I'm not sure what that's all about. It's pretty strange, pretty strange. The only other thing is this board, piggyback board that goes onto this connector right here. Must be the modulation board for this carrier thing here. Anyway. And then you can kind of see some heating on the board here. If you put over it, it got pretty ugly over here. It blistered all of the rosin flux. So this one got really, really hot for some reason. There is no protection. Well, is there protection? Yeah, there's protection. There should be a 2 amp fuse before it goes out. So I'm not sure why it didn't blow the fuse, but anyway, there it is. I'm going to cut the traces on all these connectors so I can use them for their intended purpose instead of what they're doing here. I'm sure it does what it does well. So the other thing I found was the actual part number for this mixer. It's an AC1-B-3. Don't know what that is. AC1-B-3. I have to look it up, see if I can find what this thing's used for, or maybe find schematics for it. Might be a bit helpful, although not much.